Algebra 1, Unit 8, Section 2, Quadratic Linear Systems. Similar to regular linear systems where we have two lines and we want to know where they cross, this is a quadratic linear system. And I have a quadratic, which is a graph of a parabola, and a line, a linear, and I want to know where they cross. A system is always determining the points of intersection. When it came to two lines, there's only one way for two lines to cross, really, unless it was the same line on top of each other. But for parabola, you could have at most two solutions. That doesn't mean there's always two solutions. Most of the time, it's going to be like this, where you have 1, 2 solutions. But it could be less than that. Like you could have a parabola and just crossing at like the vertex. Or it could have 0 solutions. So it is possible to have less than 2 solutions. It is not possible to have more than 2. Like you can't cross 3 times or anything like that. It's either 2, 1, or 0. Most of the time, you're going to see it crossing twice like this. Now, solving it graphically is just graph the two things. You know, I would graph the quadratic, maybe use my calculator to generate a table of values, plot the points and go. And for the linear equation, we can use y equals mx plus b. It has a y-intercept of -1 and a slope of 1, so it's up 1 over 1. And where do they cross? You know, this one crosses at 1, 0 and 4, 3. You know, so those are your two answers there. So we could solve it graphically by just simply graphing the two things, seeing where they cross visually. Or we could do it algebraically. And the way to do it algebraically, remember, whether we use f of x, g of x, it's still just representing y equals. And so because they both equal y, we could equal them to each other. And that's what we're doing here. We're just taking the trinomial from the quadratic and the binomial from the linear and setting them equal to each other. There's the trinomial and the binomial. And then once they're set equal to each other, you recognize that you're going to have to factor because you have x squared terms and x to the first terms. So the rule we learned in the last video about factoring to solve is you got to first set it equal to 0. So I minus x to make this a -5x. I added 1 to make it a 4. And then we went through the process of factoring and solving, just like in the last video, and we got 2x values. Now the difference here than what we were doing in the last video is you're not finding roots. So, like in the last video, whatever you got, like they were on the x-axis, they were x-intercepts. That's not what this is. These are not automatically, you know, (0) each. These are the x values of the points of intersection. And so this one actually does work out to be 0, but that's just a coincidence here. What you have to do with these x values is plug them back in to either equation and solve for y. You know, typically I use the linear just because it's a little bit quicker, a little shorter. So it's x minus 1, and you know 1 minus 1 is 0, so that's why we got a 0 there, and 4 minus 1 is 3, so that's why we get a 3 there. But you got to plug them in to get your 2 points of intersection. One thing you could do also with your graphing calculators, if you do have these both typed into your y equals for your graphing calculator, you can look at their tables. And what you'll see in the tables is next to the x value of 1, they're both going to have y values of 0. And next to an x value of 3, they're both going to have y values. X value of 4, they're both going to have y values of 3, meaning they're at the same spot at the same time, so that must be where they cross. Let me do an example for you on the bottom here. Solve the following systems graphically and algebraically. First, let's do graphically. So I'll use the quadratic here. And again, I'm going to use that program Desmos to generate a table. You can use your graphing calculator at home. And I already have it kind of pre-typed in for us to save a little bit of time. X squared plus 4x minus 1. You may have to move around your table a little bit to, remember you look for that where the pattern starts to change. That's going to be your vertex. And then I like to do as many points to the right, as many points to the left, as I could fit on a typical like 10 by 10 graph kind of thing. And then I typed in the linear equation too, 2x plus 2, just to kind of see. So right now I could already kind of see where the points of intersection are. But let's not worry about that yet. Let's see if we can, you know, graph these one at a time. So let me turn this off and let's just focus on the parabola first. So the first thing you're going to want to do is write this table down. So I'm going to write this table down next to our graph here. It's just a quick little table here, x, y. And the table went from -5 to -4, -3, -2, -1, 0, and 1. And that was 4, -1, -4, -5, -4, -1, and 4. Like I said, you could certainly type this into your own graphing calculator and confirm this table and generate it yourself. But I'm going to plot these points. I guess I'll stick with green. So -5, left 5, 4 is up there. -4, -1, -3, -4, -2, -5, and then the pattern goes back up. -1, -4, 0, -1, 1, 4. And do your best to draw a smooth curve. Throw some arrows on the ends. Vertex out is the best way to draw it. And so there's that. I mean, certainly not quite as good looking maybe as what your calculator can produce, but you could at least kind of compare pictures and make sure it looks somewhat accurate. Then for the linear, I don't need my calculator here. I can see that the m is 2, that's, or 2 over 1. And the b is also 2 here. That's this. And that's where we start, a y-intercept of 2 on your y-axis. And then a slope of 2 is up 2 over 1 right there. And I can see that's going to be a point of intersection, up 2 over 1. Continue the pattern back the other way, down 2 over 1, down 2 over 1, down 2 over 1. That's another point of intersection, down 2 over 1. And draw a line. I'm going to use a tool here to help me draw a nice straight blue line. Make it a little bit thinner. And just like the quadratic, throw some arrows on the end, and you got to label. So this is y equals 2x plus 2. This one over here is y equals x squared plus 4x minus 1. And label the answers. The answer here is the point 1, 4. Right, that one right there. And here, -3, -4. -3, -4. And so those are my answers. And that's how you do it graphically. You just graph it and see where they cross. Don't forget to label, and don't forget to tell me where they cross. That's the whole answer. How about algebraically? All right, so algebraically what we're going to do is, since they're both equal to y, I'm going to set them equal to each other. I always do the quadratic on the left. That's just because I like it on the left. It doesn't have to be that way. You can put it on the other side if you like. So that's my trinomial from the quadratic equals 2x plus 2 from the linear. Now I will need to set it equal to 0, and I always move the linear to the quadratic because I like x squared to stay positive. So I'm going to have to minus 2x. Now where do I minus 2x from? I do it from its like term, if it has one. And minus 2 from its like term. So this gives us a trinomial of x squared plus 2x minus 3 equals 0, right? Combine, combine. Now that it's set equal to 0, I can just go about my basic trinomial factoring here. It multiplies to -3, adds to positive 2. That's going to be 3 and 1. The signs will be, because they're combining to a positive 3 and a -1. Then when I go about and solve these factors, if I set x plus 3 equal to 0, x minus 1 equal to 0, add 1 here, add 1. So x equals 1. Minus 3, x equals -3. And that's good. I'm confirmed because I have an x value of -3 and an x value of positive 1. So I know I'm on track. But again, I need to remember that I'm not done here. That's a common mistake, is people will stop when they get x. But because we're doing coordinates, we also need to find y. So what is y? What is y? Well, again, I can use either equation. Typically, again, I like to use the linear, 2x plus 2. So that's 2 times the x plus 2. That would be a -6 plus 2, y equals 4. And again, that's confirmed there. So it might be worth it just to get the answers in your calculator first. This way you know you're getting the right things. 2 times the x plus 2 is 2 plus 2, y equals 4. Oh, wait, made a mistake here. This one is supposed to be -4. -6 plus 2 is -4. So that's confirming that one. Yeah, that makes sense. And so I would write them as coordinates too. Like for this one, I plugged in a -3. I got a -4. And that confirms that answer. This one, I plugged in a 1 and I got a 4. That confirms that answer. So that's how we could solve quadratic linear systems graphically or algebraically. It's a lot of that same set it equal to 0 factor solve kind of stuff, but we have to plug those x's back in to get the y's, and that wasn't something we had to worry about yesterday because when you're just finding the roots, automatically you know the y's are 0. So that's it, quadratic linear systems. And the next video we'll get into the quadratic formula. Talk about when your roots aren't nice, neat, whole numbers, that type of stuff. All right, see ya.